Good afternoon, everyone. My name is Charukesh Panjala, and this is my deep learning project for pattern recognition titled Weapon Detection in CCTV, a comparative study of YOLO12n. In this project, I explored how we can use artificial intelligence to detect weapons like guns, knives from the CCTV footage camera. So, why did I pick up this topic? So, nowadays, you can see CCTV cameras everywhere, like in the malls, stations, and schools. But it is impossible for people to keep watch of all the cameras all the times. So they might be missing the weapons like guns and knives. If we can use a deep learning and AI to spot these weapons, I think we can alert the right people and maybe prevent the crime. This is the main motivation behind my project. Now, the problem statement and research questions. In this, I would like to say the main problem is that the real CCTV videos are not always clear. They are blurry, crowded, and many bad lighting. So I think the AI models are trained on clean images from the internet, and when we use them on the real CCTV, they might miss the weapons or give us false alarms. So I think we need a system to be both accurate and very fast so we can actually help it in the real situations. Uh, in my project, I try to answer like some of the key questions like does the image size or the lightning affect the accuracy, or what is the effect of epochs on the accuracy, and what is the best setting of confidence, and the comparison between the latest YOLO V12 and the YOLO V8. Now there has already been done some work on this thing. Many researchers have already tried to use the deep learning and AI for the weapon detection in the CCTV. Most of them have used the YOLO models such as like V5, V7, or V8 because they are fast and work in real time. And some of them have also tried on different methods like RCNN or the efficient net, but the results were mostly good when they use clean or artificial images, and they were a little bit lower when used on the CCTV. And there are some special models for the nighttime or small weapon detection, but it does not work on all the videos. And what is lacking in this is that the real world testing and large public data sets. And now I'm going to talk about my data set. So I have used the data set from Kaggle called Guns and Knives Detection in the CCTV Videos. It is actually made by mixing up three different types of data sets. If you can see, these two are the sample images of my data set. And the data set is already divided into three parts. One is for training, validation, and the other is the test sets. And there are two classes, pistol and knives. So this data set contain different types of images like dark lightning or partly hidden weapons and crowded areas. Now talking about my methodology, it is very simple. First, I downloaded the dataset from the Kaggle and prepared my images. Then I trained the model. Also, I trained the V8 model as well. During the training, I changed the settings like batch size and epochs to get better results. And also, I used the validation images to keep check if the model is learning or not. And finally, I tested the best models on completely new images that looks like the CCTV. And in the last step, I have compared like both the models for the speed and accuracy. Now talking about the YOLO architecture. YOLO stands for you only look once, and it detects all the objects in one pass. YOLO is very fast. Mm, YOLO V12 is the latest version, which we have used in our model. And this model uses convolution layers to look for patterns in the images, and it then draws a box around the image like a gun or a knife, and then it gives us the result. So in the next step, we have trained the model. So in this slideshow, it shows how the model got trained. So the loss for both training and validation kept growing as the model learned, and then it became stable after around 12 epochs. The precision and recall and the MAP50, they were detected correctly, and it went up first and it leveled off in the end. And most of the learning happened very quickly for the first few epochs. And this is our F1 score graph and the confusion matrix. So if we can see that the F1 score for knives is very high and the pistol is a little lower, it means that our model can detect knives very well, and we have to train a little bit more for the pistols. And this is our confusion matrix. This shows like how many times the model got each class right or wrong. If you can see, most of the time knives were detected correctly, but the pistol were missed or confused with knives or background. Now after the training, we have like randomly picked up 20 images from our test set, and then we used our model to predict them. So the results have shown us that like knives were detected very much correctly and reliably almost all the time, and the pistols were missed sometimes. I think it might be due to like difficult images. Also, our model was very fast. It processed each image in less than 7 milliseconds. So it is very fast for the real-time CCTV. And if you can see this one, these were the sample images which we have used to train our model. On the top, these two were images which were detected by our model correctly. It had row of boxes on the knife and guns and gave the result. And if you can see the bottom two images, these two were missed. So it might be due to the model did not able to find the gun because of all the other items beside this one. And in here, because of the angle and the clarity, the model might have missed the gun. I think if we train our model more on little bit photos of guns, I think it might become correct in the future. And now I want to show you how our model works in real time. So now we're gonna test our model on a completely new image which we are gonna pick from Google. So first, CCTV weapon images. What are the images? Yep. I think this one would be fine. Let's see. Saving the image to downloads, test, save. So this is our Kaggle notebook. I have already trained a model. So first, what we did is like here we just explored our data set. So these are the some of the sample images, and then after that we have installed the Ultralytics package. So we are going to use the YOLO model from the Ultralytics. So we are using the YOLO12n model, which is the latest one. We have included that one in the model one. Then in here we are training the model. So this is the link for our data set. We are training it for 15 epochs, image size 640 and 16 batches. I mean, for every batch, it will get trained for 16 images. And then after all the training is done, it took around half an hour for the training to complete. These are all the things. So if you check the test results, This is our overall result overview, and this is the F1 confidence curve. For knife, it is a little bit higher than the pistol, and this is our precision recoil curve. Even for this, it is a little higher than the pistol, and this is the precision confidence curve. It is almost same for both of them, and this is the recoil confidence curve. Here also the knife is leading, and this is the confusion matrix. You can see like the knife is more than the pistol, and this is the normalized confusion matrix. And these are all the research questions which we have done, and I think we already discussed about this in our previous video. And so now let's create a new data set. Yeah, this is a picture. Test data. Yep. Yeah, data set is created. So if you check here, I imported the YOLO and I've used the best one from our training. So the best model gets saved over here inside the weights. So I'm running this. Yep, the model is loaded. Now here we are using this one from our test data set. See, our file is test.png and dataset is test data. Yep. So we are predicting. Yeah, the prediction is done. If you can see, the result is saved to predict.3. So here like we are importing image from PL. PL is actually Python image library. This is used to read the images, and we are using this PLT. So this is mostly used when we work with images to show them and print. So this is our file test.png. It got saved in predict.3. Okay, now let's see the results. Runs detect predict 3 test.png. Let's reload and see what had happened. Eagle slash bookings runs. Okay, detect slash PRAT predict 3. Okay, test.jpg. Yep, I think it's C. Yeah, I think our model like had detected the pistol in the person's hand, but also we got a false positive over here, like because of the shape of the chair and dim lighting over here. I think our model falsely predicted this chair as a pistol number 2, but I think it did a good job finding the real pistol. But I think to overcome this issue, we have to train our model more on the gun data sets. Mm, by this, like, I want to conclude that YOLO12n is a little fast and it works very well for knife compared to the pistols. And the pistol detection is little more difficult because, as you see, the model got confused and it also missed sometimes. Thank you. I'm gonna end it.